I think in the same discussion, we have a similar kind of initiative taken by. On behalf of the entire audience, I request Professor Srinivas to share his experience and the product what he has developed, and I also request him to lead the, like we have the several domains, as Professor Vijay is taking up the machine learning and related areas, and I also request Professor Srinivas to take up the wireless and wireless sensing, sensor networks, though we did small sensors interfacing, but this is beyond, so much of things has to be done. So being he has already made a product, so I openly requesting on behalf of all of the audience to take him and lead further this particular domain. And in a similar way, I do not know much of you, so I request after the lunch to share your experience and lead it in officially, like, so that there are the people knows about in which area you are working, and if there is a similar work done, we could able to share and brought together and utilize that across the institutions, and that was an idea.
The context here is I taught this computer networks and mobile networks for quite some time, and every time I was teaching, my frustration was going up, you know. So because we always teach distance vector and, you know, all the routing algorithms and power minimization, all that, everything at the end of it, the same questions, you know. In the exam also 4 nodes I'll give, and you give the what is the input node and what is the, you know, output node that you have to get the data, and just design a routing algorithm. So every time I was thinking, oh God, beyond this can we do something? Because unless people have an experience of having the nodes with them and actually designing an algorithm to actually, you know, wirelessly show how it is, and in a lifetime, even if you read computer networks from any of the standard books for 10 times, you may not have an opportunity to even see a packet, how a 802.11 packet is, you know. So this kind of things were frustrating us. Then we suddenly thought about a couple of months ago, why don't we just design a very simple system where actually people can hold the nodes in their hands and actually see how the data is coming from me to her to him, or the routing is changing. How can we do this? So this was the context with which we started thinking about building a very simple system. So that's where the sensor network that we just came up. And of course I have to really acknowledge my close friend Srikanth, who is a wizard in hardware. Okay, he had a very close collaboration with him, and we designed together, and today it's taken nice shape. Of course, right now it is in particular stage, and probably after 3-4 months, when I complete some work with my MTech student who is going to do some work, after 3-4 months, I think we'll have a substantial things to showcase as a part of this. Okay, so do you have white? So the idea here is I have a base station, and I have several nodes here. Okay, so I can design a base station, all these nodes, and the first cut idea is I can just have a star network, right? All these nodes, I can write a firmware where every 10 seconds or 20 seconds or 1 minute, based on the nature of your data, it could be measuring some values and sending it to the base station. This base station, I can connect it to my laptop, and I can apply whatever Dr. Vijay Kumar suggested, you know, machine learning algorithms or data mining algorithms, all that I can apply. I can derive a lot of inferencing out of the data that I get. So this is the basic model with which we conceptualized, and right now it's a star network. I'm going to show you, and you can hold this and get a feel for it also. So right now I measure the sensor that two sensors that the nodes has a temperature sensor and an accelerometer, only 2 right now. And there is a provision, I'll tell you, there's a provision. We have brought out all the 34 GPIOs of the PIC microcontroller outside, so I can actually interface any other sensor of my interest, be it medical or agriculture or whatever. So
yeah, we can switch it on.
Yeah.
As you switch on, the LEDs will come on, indicating that it starts transmitting information.
And base station?
Yeah, the base station, we have two different kinds of base station. We have 2 sets. This is the base station with some 6 nodes. This is another base station with another 6 nodes. They can identify each other with the help of certain numbers. They have unique IP
MAC,
numbers.
MAC number, so that, yeah.
Now, one is provided with the USB interface, which you can connect to a laptop, and other one is with the Bluetooth interface. So you can have a small app running on the mobile phone. So whatever data you are capturing, that can come directly onto the mobile, as long as it is within the Bluetooth range of the base station. So I'll just give a few of them.
Okay, just coming to the internals, no, this is RF. It's a standalone. This is purely meant for a dock network, setting up a dock network, right? Infrastructureless dock network. So right now, as soon as I turn it on, you can see the LEDs. So the firmware has been written in such a way that the first LED is the power on LED. The second LED is it sends the data. The other one is it receives the data. Of course, I can configure in whatever way I want. Okay. So right now the firmware is every 20 seconds the data is going to it will measure from this ambience and it's going to go to the base station, which should be located about 100 meters from this node. Okay. So after 20 seconds you will see one LED to glow, so that means the second set of data is gone, so I can start collecting. So right now it is a star network where I can start collecting the data and I can aggregate the data in my laptop or in my device, mobile device, whatever. So as my colleague said, I have a wired interface, USB interface, as well as a Bluetooth interface. In either in one of the things I can have all the data here. So this is this works in the 2.4 gigahertz ISI band, so there is no worry about the usage of the band and so on. So it uses a PIC microcontroller, right? It has got an inbuilt memory, it has got an inbuilt battery. It runs in a AA batteries here. So the best part of this is a very good, the sleep cycle pattern has been designed in this so that it doesn't wake up. The first cut thing that you can do is I can just turn it on and leave it forever. So that means within 2 days or 3 days it keeps sending the data every 20 seconds and after 2 days the battery is out. So the sleep cycles have been designed in such a way that as soon as it sends the data and it goes to sleep mode, and next time only after 20 seconds it wakes up and sends the data again. So we've also designed a small switch so that if it is not in use, there is no point in this sending all data all the time. So this is one, and the next level of things that we are planning to do right away is if I have, let's say, multi-hop kind of thing, So if this node, it is not in the radio range of this, it may have to transmit to this and then it may have to transmit to this, right? Or based on your distance vector or any of the wireless routing protocols also, the best route may be this to this to this to this. So at the node, this decision doesn't have to be taken. I can take all the decision in a central server or something like that, and then I can put that program all here, and only the routing table, update can be sent from this PC via the base station to all the nodes. So right now we are trying to do a multi-hop protocol where we could design all the state-of-the-art, whatever latest protocols that you have, which are done mostly in the theoretical kind of way. I can actually implement all of this and I can make it happen. And the best part, the most enjoyable part for us was a team of students were working, and I'm talking of earlier context, okay? So whenever I say, okay, I'm going to teach distance vector routing for you, the students would again say, okay, it's all in the book, I can again, he's telling the same thing. But the best enjoyable part was we asked them to implement the same thing on the nodes. So one student would be sitting in one part of the campus, the other is near the security, the other near the admin block, and we had an interface. I'm talking of an alternative thing that we had. So right now we are going to do that here also. So we had an interface where all the data was coming in, and it used to show what was the route it was taking to actually reach the base station. So graphically it used to show everything. When I saw this kit, the first thing that came to mind was easily you can implement the same thing here. So as soon as, for example, in my campus, PES campus, I had set up a network and all the communication was happening. Now I'll tell my friend, can you please switch off your device? As soon as it switches off, now the routing algorithm knows that that node is actually not available. So it has to find another optimal path to actually reroute the thing. So nicely you will see that the data which was coming through me is actually going through somebody else. So people can actually hold the devices and actually get a feel the data is actually not going through me now, it is going through some other path. So this multi-hop algorithm is going to be a very, very interesting thing that we are going to complete maybe another 2 months or 3 months. And one more, as I said earlier, one more most interesting thing is how do you minimize the power? In ad hoc network, the very key problem is what is the mechanism to minimize the power. Okay, so no doubt all the CSMA CD, collision detection, avoidance, all that is implemented here. But the thing is, if you don't let the nodes to wake up at the right moment, for example, if I take this node for example, if all these nodes have to send data to this node and then if it has to go to the base station, then this node will be active all the time. If node is waking up all the time, then the battery will get depleted. So what is the best mechanism to make sure that I optimize the power so that one single node doesn't deplete its power? Can reroute, and we should see any other intelligent mechanisms that we need to use for that. Yeah. So the power minimization is a very, very key problem in ad hoc network, and lots of IEEE papers are coming up these days. We are just thinking how best to take some or modify some to the ad hoc network environment and quickly implement some power minimization algorithms also here. So I think just to wrap up the discussion, what we are saying is whatever we are doing till now and teaching that is happening and research that is happening, and most of the time whenever somebody is doing research on all these wireless ad hoc networks and so on, they'll immediately go to the NS2 simulator and actually create some nodes, and it's good. I mean, we are not saying that NS2 is bad or something, but it doesn't give a feel for exactly how these are implemented. Okay, on the NS2 gives nice graphs of call drop and how many calls are going through, what's the throughput, all that. But here you can get a physical feel for all this by using this. So I feel it makes a lot of difference if I actually carry it to my classroom and actually set up a small network inside the classroom and actually teach the wireless routing protocol, rather than to, again go by my PowerPoint and actually teaching all that. So I think again it supports Dr. Reddy's philosophy that the teaching has to be, hands-on.
You can actually see the packet format, and what should be sent in the packet format you can decide. If you have multiple sensors, there is also an interface to connect additional sensors. So
right now you can add it. I mean, that can also be one of the add-on.
The provision for adding additional sensors depending upon the network, and which packet format, in the format in which cell it is going to send that information, that can be also configured. And from the collected data, where it has to populate which database, that also we can have it in the cloud, and it can be accessible elsewhere. So that's a kind of total work, and this has been done by students not more senior than the first semester students during an internship for about 6 weeks in our college last summer, 2015 summer. We invited people from different intelligence students, of course, from all branches, including electrical, electronics, telecom, ECE, and they have done a project with us for 6 weeks. Some teams have done the power optimization, and other teams have done different type of routing protocols, and also understanding this to the threadbare details, going into the packet levels and how to modify and how to So all this was done by our students and it's all well documented. Now we are taking up to the next stage of giving a descriptive, like HP OpenView, if you're familiar with that. Something similar to HP OpenView where you can actually see which node is transmitted and where the connections are occurring. So that kind of thing is in our agenda for the next coming year.
A few of the good, sorry.
Sir, in this present system of use, you are using app or some software at your PC?
Actually, a small app was developed by Srikanth, who helped us with this hardware to actually see which node is sending the data and first cut, where the data is going, whether it's going from 1 to 2 to 3 or 1 to 3 and so on. But as you rightly said, this is the best candidate for actually putting everything into an app, and the app should exactly give you the present configuration of where the loads are located. See, once this is done, the applications are umpteen. One of the applications that I can say is in Australia, this wild dog attack is so much prevalent. These sheep farmers, there is so much land there. About each farmer will have about 5,000 sheep, and it may be grazing some 5-10 kilometers all around. So they're really looking for technologies where if you have some small collars on each of the sheep, and actually the data could be coming to a farmhouse or something like that. So sitting on his terminal, you can actually visualize which sheep is where, whether some dog attack has happened. Hundreds of dogs get killed because of the sheep attack. So you can actually sit in a farmhouse and actually visualize how the sheep, whether it's in a safe zone or does he have to go and attend to the sheep. So there are umpteen applications once this infrastructure is available. I mean, oh, okay. See, certainly it's a good question. The sensing part is left to your application, whether it's a body health parameter sensing or agricultural sensing, that you can always address, The main thing we are talking about is the back-end infrastructure, networking and infrastructure. So sensing part, if it's a medical, it's a altogether different thing. If it's a agriculture, it's a different thing. So
If I have Wi-Fi, can this machine
why not? See, most of the devices today are Bluetooth enabled, So since this is Bluetooth enabled, through the Bluetooth it can come to this device. If it comes to one node, then through a multi-hop it can reach the server or base station, whatever you're talking about, So it depends on your specific scenario. But this is one generic network that we have built, but you can fine-tune it to any of the requirements that you're talking about,
The Mobility Research Forum stands as a global platform for all of you to showcase. Now friends, this is an era where the compartmentalization has gone. Means that we need to have collaborative research. You are all faculty members from different institutions, so therefore talent lies in among students belonging to different branches. So therefore, in order to evolve a product for this country and in general at global level, it is necessary that we need to allow the students coming from every branch of engineering form a conglomerate group. So attract students coming from different areas. It gives a clear impression how things are really happening. That might basically create a more interest among the students to do something different basically. So therefore, we have sensors, we have mobile platforms today, open source technologies available today, and we have understood small experiments. It's a right step in the good direction, and we need to really take it at different levels now. The challenges are plenty for all of us, because look at the bigger picture. When I met actually Dr. Murali Mohan at DST in Delhi, he was having a very big project for data science and data mining applications using machine learning techniques. The big project is actually on the portal, where most of you will be the stakeholders. Now we want to integrate Murali Mohan is in the data mining group. This specifically is looking into this data mining using machine learning. One of this. Okay, wonderful. So the projects that India government is unfolding is a challenging opportunity. So they want to integrate all the rivers in India. So it's going to create a huge database, and data mining is necessary. Now where we can really apply. This is a big project. Now how we are going to do is a big thing. Now you need to develop a project, and then they invite you to present your thoughts, and that could be your area for lifetime. And again, the cyber physical systems. Now we have a cyber technology. Physical systems include all your sensors, your servers, and so on. Now can we really come out with efficient techniques and methods that really works for prediction of hurricanes, tsunamis? Okay, and can we save our erosion, soil erosion? So many things are spread across. It's a very huge picture for each one of us to really generate the next generation engineers. So therefore, friends, this is a very small platform today, but with all your efforts, it can really go to a bigger platform. And we believe that the Microsoft is going to support us. We need to have more such interactions. And when we meet next time, we need each one of you to showcase something different. Now there has to be, because we have spent money, we have spent time, and there has to be an outcome. So I always believe in outcomes. It's not simply taking something and then going back and so on. We need to be more result oriented. So all our effort and time will not come back. It goes to history, but we want to rewrite the history by producing more better things in the coming years. So I would basically support anything related to machine learning, and also we have done some considerable effort on IEEE 802.11. My colleague Shiv Prakash has done considerable work on energy optimization by switching into different modes: light sleep, deep sleep, and active mode. And we are going to implement at Mac layer. So this what is a Russian university, St. Petersburg State University collaboration works we are doing. So that can go to different mobile devices to optimize the energy levels. So if you want any kind of interactions with our group on machine learning or mobile ad hoc networks, energy optimization, we can always help you. And cognitive computing is an area for the future. Whatever you want to have, you need to have an element of cognitive computing to inbuild certain level of intelligence to make it work in a better way like a human being. So you will see these kind of things in the future. In the next century belongs to cognitive processing of information. So with this, I thank all of you for taking so much of interest, and I believe that all of you are going to be more result oriented in the future and contribute to the expansion of MRF activities. Any suggestion, you can always write to us. We will always come back to us with the solutions, and we will provide every opportunity for individual growth, so that collectively we can always participate and hold a international level conference with all your support at different places in the future, so that we can show to the world that yes, we can do something different. Thank you very much.
Thank you, sir, for all these things are not planned. I think certain innovations you never plan it. It happens it. So it happens it today. I think the leading by Professor Srinivas, Professor Dr. Vijay Kumar, and Professor Nagabhushan. I am sure that many of you have such initiatives, and we would take up rather putting at isolated locations, and let us have a discussion and support one-to-one and make it a bigger picture, as Professor said. I hope that this will lead to a good conference further. Maybe we could plan it in the summer, either at Bangalore or at Delhi or any other place, and contribute not only the papers, but we should come up with the showcasing the products. Maybe a session, maybe 10 different products, a 2-day or 3-day event, showcasing how you have built, how you have customized, and you could share that products to other people. I think we request with Suresh and other forums and contribution from the industry as well. So I appreciate your being listening and interacting. Let's have a lunch. I hope that they are waiting for us. After the lunch, we will come back and have a